Inductive reasoning is not perfect. Errors can be made. So it's important to test your conjecture multiple times. As you're testing your conjecture, be looking for a counterexample. A counterexample is an example that shows that a conjecture is not always true. Now, an interesting thing about mathematics is we deal in absolutes. So instead of saying not always true, we are actually going to say false. If you can find a single counterexample that proves that your conjecture is false. Let's try this really quick. What is a counterexample to each conjecture? The first conjecture is, if the name of a month starts with J, then it is a summer month. June and July are both summer months. However, January is a winter month. So there is a counterexample to prove that conjecture is false. You can connect any 3 points to form a triangle. That does seem to be true, because if I choose 3 points, then I can create a triangle out of them. And look, here's another 3 points, and I can create a triangle out of them. This is why we do multiple tests to look for a counterexample. What about these 3 points right here? I cannot create a triangle because they are collinear. So 3 collinear points is a counterexample to this conjecture. And finally, when you multiply a number by 2, the product is greater than the original number. So if we take a number, say 6, and multiply that by 2, we're going to get 12. And the product is indeed greater than 6. Let's try another number. 8 times 2 is 16. Well, 16 is still greater than 8. Oh, 0 times 2 is 0. Is 0 greater than 0? It is not. 0 is equal to 0. 0 is a counterexample. Also, think about this, negative numbers. Negative 3 times 2 is negative 6. But negative 6 is less than negative 3. So negative numbers are also a counterexample to this one.